Okay, so what we're going to look at tonight is what is the disease of addiction? You know, addiction and the brain reward system, which is really important to look at. What we want to go into is how the brain actually works. You've got your prefrontal cortex, your nuclear and your ventral areas. Now, what we see is that with addiction, the reward system of the brain is what is affected. That's where we eat, drink, procreate. That area of the brain is what we call the pleasure system works, and it releases the endorphins, etc. So the brain releases those chemicals that we would normally use for eating and sustainability. But yet when we start using alcohol and drugs, there's an enhanced release, and this is how addiction actually comes about. People start to actually want more and more. I don't know, Kate, if you're able to move the screen. Can we bring up some slides at all? Can I go to the next one?
Clive, is this okay?
Yes, I just can't hear anything.
To understand the complexities of addiction and its neurobiology,
Can you hear?
it's important to understand the brain's reward pathway. Information travels through the VTA area to the nucleus accumbens to the prefrontal cortex. These reward pathways make us feel pleasure and are activated by stimuli such as food, water, or sex. These same areas are also involved in addiction. Alcohol and drug use changes the way the brain works. You can see a normal functioning brain on the left and the abnormal functioning addicted brain on the right. Prolonged use of alcohol and drugs also changes the structure of the brain. You can see the normal healthy brain structure on the left and the abnormal addicted brain structure on the right, which could be long-lasting.
Hope you got a bit of an idea there from that video, what I was trying to explain with the reward system. So what we're saying is that drug addiction changes the brain, okay? We all have receptors, and especially the dopamine receptors are lower in addiction. So you'll actually see we've done a graph of a controlled and an addicted brain. On the left-hand side, you're controlled, and then the right is the addicted brain. And you can see how the receptors are highlighted and are lower in addiction. So you can see the difference between the cocaine and the meth and the alcohol versus a normal. So you can see how the normal and what happens in an addicted brain. The next slide, if possible.
Next.
No.
Want to go back, Clive, or is this one?
Forward.
Okay.
Okay, so addiction is like other diseases. It is preventable, it is treatable, and it changes the biology. If untreated, it can last a lifetime. And we often say that the disease of addiction is the obsession of the mind and the compulsion of the body. So the mind actually thinks of the drugs all the time, and the body just wants those drugs. So there's the craving and the obsession and the compulsion. Could we go to the next slide? Okay. So understanding the
It's important to understand that everyone in the world has addictions, or rather natural addictions, to things that are good, like food, water, and sleep. These natural addictions are important for our health and survival, and without them, we would not hunger or crave the things we need to survive. Now, we aren't exactly born with these natural addictions. Our body creates them. Let's look at an example. When you bite into an apple, your brain says, yum. Your brain recognizes that this apple is good for you. It has nutrition, vitamins, and gives your body the energy it needs to survive. Whenever the brain recognizes something that's good, it releases a chemical called dopamine. Dopamine causes you to experience pleasure. It's what makes you feel good, like when biting into an apple. The brain releases this dopamine in order to teach the body that this is healthy and good for your survival, and that it should remember to do it again. Now, there are other things we do that can release the pleasurable dopamine, like playing video games, exercising, or reading a good book. However, the amount of dopamine released during these activities is less than what's released when we eat food. The brain does this so it can recognize which is more important. So if you go 2 days without reading a book, or 2 days without eating food, your body is going to crave the food over the book. As such, your brain creates what's called a hierarchy of survival, which ranks how important each of these things is to your survival. Now, there are some things that will not cause the release of dopamine, like eating soap or punching yourself in the face. The brain knows that these things are not good and therefore does not release the pleasurable dopamine because your brain does not want you to do it again. Now, let's look at alcohol, marijuana, tobacco, and other drugs. These are all classified carcinogens, proven to cause cancer and other fatal diseases. Now, your brain should recognize that these things are harmful to your body. However, these substances have special chemical characteristics that fool the brain into releasing dopamine, oftentimes in much greater amounts than the body has ever experienced before. Because of this, the body is fooled into thinking that these things are good and important, sometimes even more important than food, water, or sleep, and consequently hijacks the #1 spot in your survival hierarchy. So now, if you go 2 days without eating or 2 days without drinking alcohol, your body will actually crave the alcohol over the food. This is an extreme case of addiction, where the person addicted believes that they will die if they don't get it. The severity of the addiction depends on where the alcohol or drug lies within your hierarchy of survival, and can increase even with casual use. Research shows that people under the age of 21 are at the highest risk of having their survival hierarchy hijacked. Why? Because their brains are still growing and developing and are hypersensitive to false shocks of dopamine caused by these harmful substances. By 21, the brain is more fully developed and mature, and the survival hierarchy becomes more permanent and less susceptible to getting hijacked. The flip side is that once you are 21, it becomes very difficult to remove these harmful substances from your survival hierarchy. Studies show that 9 out of 10 people who currently struggle with addiction started drinking, smoking, or using before the age of 21. Understanding addiction as a preventable disease can help save millions of lives. The decision to wait until 21 could mean the difference between a life enslaved by addiction or a life full of success and accomplishment. Want to learn more? Visit us at wait21.org.
Thank you. This is actually a very interesting video, and it was a study done with rats. They put rats into a cage and were feeding them cocaine, and the rats drank the water and were drinking this water all the time. They then took in and gave the rats something else. They gave them another stimulation of more care and toys and stuff in the cages. And the distraction of the healthy stuff, they didn't go to the water. They didn't go for the cocaine. So it's important to see that, like, in a healthy situation, even the rats won't go to the drugs at any level. Can we move there?
Did you want to play this one, Clive? No.
Let's play the video just to show you
I don't
what.
know if it will. Let's try.
Thank you.
Okay, so yeah, it's not available.
Unavailable. Okay. So if we look at what influences addiction, preventing and treating addiction effectively requires an understanding of multiple factors that predispose the individual to addiction. And that we call is the biological, social, and physiological factors. And it's called the biopsychosocial framework. And we look at, when we're going through that, the psychological, the biological, and the social issues that can be worked. That can carry on. Like if we look at it in biological, often the genetic predisposition. So there's a lot of examples there, which I'll go through a little bit later as well. So if you can change the slide. Okay.
The side or next one?
I think this, you look, we're seeing here long-term health conditions are biological in origin and but the impact has been felt physically, psychologically, and socially. You know, long-term, we see that a lot of things, so we often will look at the pathology, the disease, what other symptoms around, is there depression, is there another mental disorder? We also will look at what the hobbies are of the person, what careers, where they are in their lives, etc. Could we go on to the next question, slide? Want to try that video?
What keeps us healthy and happy as we go through life? If you were going to invest now in your future best self, where would you put your time and your energy? There was a recent survey of millennials asking them what their most important life goals were. And over 80% said that a major life goal for them was to get rich. And another 50% of those same young adults said that another major life goal was to become famous. And we're constantly told to lean into work, to push harder and achieve more. We're given the impression that these are the things that we need to go after in order to have a good life. Pictures of entire lives, of the choices that people make and how those choices work out for them, those pictures are almost impossible to get. Most of what we know about human life, we know from asking people to remember the past. And as we know, hindsight is anything but 20/20. We forget vast amounts of what happens to us in life, and sometimes memory is downright creative. But what if we could watch entire lives as they unfold through time? What if we could study people from the time that they were teenagers all the way into old age to see what really keeps people happy and healthy? We did that. The Harvard study of adult development may be the longest study of adult life that's ever been done. For 75 years, we've tracked the lives of 724 men. Year after year, asking about their work, their home lives, their health, and of course, asking all along the way without knowing how their life stories were going to turn out. Studies like this are exceedingly rare. Almost all projects of this kind fall apart within a decade because too many people drop out of the study, or funding for the research dries up, or the researchers get distracted, or they die, and nobody moves the ball further down the field. But through a combination of luck and the persistence of several generations of researchers, this study has survived. About 60 of our original 724 men are still alive, still participating in the study, most of them in their 90s. And we are now beginning to study the more than 2,000 children of these men. And I'm the fourth director of the study. Since 1938, we've tracked the lives of two groups of men. The first group started in the study when they were sophomores at Harvard College. They all finished college during World War II, and then most went off to serve in the war. And the second group that we've followed was a group of boys from Boston's poorest neighborhoods. Boys who were chosen for the study specifically because they were from some of the most troubled and disadvantaged families in the Boston of the 1930s. Most lived in tenements, many without hot and cold running water. When they entered the study, all of these teenagers were interviewed, they were given medical exams. We went to their homes and we interviewed their parents. And then these teenagers grew up into adults who entered all walks of life. They became factory workers and lawyers and bricklayers and doctors, one president of the United States. Some developed alcoholism, a few developed schizophrenia. Some climbed the social ladder from the bottom all the way to the very top, and some made that journey in the opposite direction. The founders of this study would never in their wildest dreams have imagined that I would be standing here today, 75 years later, telling you that the study still continues. Every 2 years, our patient and dedicated research staff calls up our men and asks them if we can send them yet one more set of questions about their lives. Many of the inner city Boston men ask us, "Why do you keep wanting to study me? My life just isn't that interesting." The Harvard men never asked that question. To get the clearest.
Could you move to the next slide? Sorry, guys. I think we're just going to need to skip a few things here. Okay, so, I think that a lot of us look at a situation and everybody wants what we call the ideal relationship, the kids, the house, the picket fence, that's what everybody's going for. But like when we start to look at real life now, a lot of things change, and the way life is progressing is unbelievable. The amount of stuff on social media and the information we're getting is coming to us at like nanoseconds. Can we go to the next one? Sorry. Okay, next slide. So what is the brain disease? What are the risk factors? If we can just skip that as well. The vocabulary, drug use, that's drug abuse, addiction, reward system, and tolerance. That's what we've been going to be speaking of, and that's what I'm going to be emphasizing as I go further on. Okay, what is drug abuse? Drug abuse is the use of illegal drugs or misuse of prescription or over-the-counter drugs with negative consequences. Drug abuse is a choice. Drug abuse is a choice the first time it happens. What is addiction? Addiction is a continued compulsive abuse of drugs despite knowing the negative health and social consequences. Addiction is a disorder of the brain's reward system and can result in long-term physical and functional changes of the brain. An important thing to know that addiction isn't just limited to drugs. We can skip this video. I don't want to do that. Okay. The reward system of the brain is a collection of brain structures and areas which regulates behavior by causing a feeling of satisfaction. We feel rewarded when we perform tasks that ensure our survival or the survival of our species. Examples of eating good food, forming bonds through social interactions. Drugs stimulates the reward system. Addictive drugs have chemical hooks that produce a sense of reward. This gives a false signal of a fitness of survival benefits. Drugs hijack the brain's reward system by replacing that healthy routine with unhealthy stuff that happens. If someone continues to repeatedly use drugs, they may develop a tolerance, which is a lower response to that drug. So a higher dose of the drug is needed to achieve the same original effects. And that's with the reward system. The body tries to balance it out and to level it to actually so that we have a balance. But so we actually get this tolerance that we've got to use more and more of the drugs. We could go on to the next slide.
Neurons, which are cells in the brain, are not physically connected to each other. Neurons communicate to each other through tiny molecules called neurotransmitters. Neurotransmitters are like keys that fit into the receptor sites of another neuron. When these molecules are released, and when they bind to a receptor, a message in the brain is transmitted. Drugs either mimic dopamine, spike dopamine, or fail to mop up excessive dopamine in the brain, creating an overstimulation in the reward center. After long-term stimulation, the brain's defense system kicks in and tries to correct the chemical imbalances. After some time, the brain gets to the point where it actually anticipates this overstimulation of the reward center, and it responds in a defensive reaction. Because of the brain's natural reaction to the continued spike of dopamine and the overstimulation of the reward center, an increase of drugs are required to get the same desired effect, and addicts may have to use more drugs just to stave off withdrawal symptoms.
I think what's important here as well is that what we talk about, the disease of addiction, it's progressive and it gets worse and worse as time goes on. It's a progressive disease.
I think we've done this one here.
Okay, we've done that. We've done that as well. I think we can go on to the slides now.
We could go on to Clive's presentation, please, Kate.
Is it up?
The next
slide.
Okay, so the disease model, understanding addiction. The disease model of understanding addiction is clinically referred to as a substance use disorder. It's a complex disease of the brain and body that involves compulsive use of one or more substances despite serious health and social consequences. Addiction disrupts regions in the brain that are responsible for the reward, the motivation, learning, judgment, and memory. The disease model of addiction is defined as a disease by most medical associations, including the American Medical Association and the American Society of Addiction Medicine. Like diabetes, cancer, and heart disease, addiction is caused by a combination of behavioral, psychological, and environmental and biological factors. Genetic risk factors account for about half of the likelihood that an individual will develop addiction. Okay. Addiction involves changes in the functioning of the brain and body due to persistent use of the alcohol and other substances. Consequences of untreated addiction often include other physical and mental health disorders that require medical attention. If left untreated over time, addiction becomes more severe, disabling, and life-threatening. Next slide. How substance use changes the brain. People feel pleasure when basic needs, and that's what we were discussing earlier on, needs such as hunger, thirst, and sex are satisfied. In most cases, these feelings of pleasure are caused by the release of certain chemicals. As we know now, it's the dopamines, which reinforces these life-sustaining functions by incentivizing the individual to repeat the behaviors that produce these rewarding feelings, i.e. eating, drinking, and procreating. Most addictive substances cause the brain to release high levels of the same chemical that are associated with the natural pleasures or rewards. Over time, continued release of these chemicals causes changes in the brain system involved in reward, motivation, and memory. The brain tries to get back to a balance of state by minimizing its reactions to the rewarding chemicals or releasing stress hormones. And as we said, as a result, a person may need an increasing amount of substances just to feel closer to normal. The individual may experience intense desires and cravings for the substances and will continue to use it despite harmful or dangerous consequences. The person may also prefer the substance to other healthy pleasures and may lose interest in normal life activities. In the most chronic form of the disease, a severe substance use disorder can cause people to stop caring about their own or other well-beings or survival. These changes in the brain can remain for a long time, even after the person stops using substances. It is believed that these changes may leave those with addiction vulnerable to physical and environmental cues that they associate with the substance use. This is also known as triggers, which means they have an increased risk of relapse. Next. Okay. Why is willpower not enough? The initial and early decision to use substances are based on a large part on a person's free or conscious choice, often influenced by their culture and environment. Certain factors such as family history of addiction, trauma, or inadequately treated mental health disorders such as depression and anxiety may make people more susceptible to substance use disorders than others. Once the brain has been changed by addiction, that choice or willpower becomes impaired. Perhaps the most defining symptom of addiction is the loss of control over the substance use. Next slide. Okay. Are people who are addicted responsible for their actions? People do not choose how their brain and body respond to substances, which is why people with addiction cannot control their use while others can. People with addiction can still stop using substances. It's just much harder than it is for someone who doesn't have an addictive personality. People with addiction should not be blamed for having a disease, but rather be able to get quality evidence-based care to address it. With the help and support of family, friends, and peers to stay in treatment, they increase chances of recovery and survival. It's so much better. The longer they're in treatment, the better the chances of them maintaining and not relapsing are. But I have the next slide. Okay. Is it a chronic disease? A chronic disease is a long-lasting condition that can be controlled but not cured. And I think this is emphasized there. It can be controlled, there's no cure. Most people who engage in substance use do not develop addiction. And many people who do so to a problematic extent, such as young people during high school and college years, tend to reduce their uses once they take on more adult responsibilities. Still, about 25 to 50% of people with substance use problems develop severe chronic disorders. For them, addiction is a progressive, as I was saying before, relapsing disease that requires intensive treatment and continued aftercare, monitoring, and family or peer support to manage their recovery. The good news is that even the most severe chronic forms of this disorder can be manageable, and usually with long-term treatment and continued monitoring and support for recovery. Next slide. Okay. Why some people say addiction is not a disease? Some people think addiction cannot be a disease because it's caused by the individual's choice to use the substance. While the first use or early stage use may be by choice, once the brain has been changed by addiction, most experts believe that that person loses control of their behavior. Choice does not determine whether something is a disease. Heart disease, diabetes, and some forms of cancer involve personal choices like diet, exercise, sun exposure, etc. A disease is what happens to the body as a result of those choices. Others argue that addiction is not a disease because some people with addiction get better without treatment. People with mild substance use disorders may recover with very little or no treatment. People with the most serious forms of addiction usually need intensive treatment, followed by lifelong management of the disease. However, some people with severe addiction stop drinking or using substances without treatment, usually after experiencing a serious family, social, occupational, physical, or spiritual crisis. Others achieve recovery by attending the self-help, the 12-step fellowship, AANA, and they often will go to those meetings without receiving much more. If any professional treatment, without any professional treatment, in all cases, professional treatment and the range of recovery supports should be available and accessible to anybody who develops a substance use disorder. I think it's that the last slide there.
Yeah, that's it.
Yeah. So I just really want to come back to you, and if there are questions about, the disease of addiction, and I know in the beginning it was a little bit mixed up, we're here to raise your hands, tell us what questions you want, and we'll try and answer them as best as possible.
We recommend in the first year of sobriety, of total sobriety, ongoing abstinence, that they try not to seek out adrenaline-based highs because they're not emotionally equipped to deal with it. And it definitely triggers something somewhere. And it's almost like we were having a conversation today in the clinic about non-alcoholic beers and non-alcoholic beverages. And, there's not supposed to be alcohol. There's a small amount of alcohol in them, but it's the association. And that association triggers something for an addict. And we got to bear in mind, they've got a disease of more. So nothing is ever really enough for them. So if they go bungee jumping, the thrill is incredible. The adrenaline it courses through their veins. And a day or two later, they have a hangover, like an emotional crash. And they can't always go and bungee jump again or scuba dive or mountain climb. So often then the next step is, well, whatever it was that got me high previously, I'll use. It's quicker. So sometimes it's an unconscious process, sometimes it's conscious, but we ask them not to get piercings, tattoos, and do adrenaline-based sports for at least 12 months of sobriety.
And I think what's important there as well is once the person comes into treatment, we're trying to normalize the levels so that they're going back to a normal level, so that as soon as something of an adrenaline rush, it's putting the brain and the chemicals out of kilter again. And I think that the sad thing is that the addictive mind is always looking for that pleasurable high. And what we're trying to do is get it back to normal. So it can trigger stuff in the first year, and we always say, do it with caution.